Welcome to another deep dive. Today we're going to be looking into something you've been thinking about, and that's the world of shapes and patterns and I guess how they sort of connect to bigger ideas about reality. You've been seeing hexagons everywhere, right?
Yeah, you've really been noticing them like everywhere, from honeycombs to ocean waves, even snowflakes and the cracks on the Earth's surface. It's um, it's quite remarkable how you're putting all these together.
Yeah, it all started for me, honestly. I was just thinking of honeycombs. It's so fascinating. The perfect little hexagons. I mean, they're just so mesmerizing. But then I started seeing them everywhere.
And that's what's so interesting about this. It's not just a coincidence. Hexagons are kind of nature's go-to shape.
Hmm.
When it comes to efficiency, I mean, think about it. Circles are great for enclosing a space. But when you try to pack them together, you always end up with these gaps, right?
Mhm.
But hexagons, they fit together perfectly. They maximize space while using the least amount of material.
So it's almost like nature's a master engineer looking for the most economical solution all the time.
Exactly. And we see this principle applied way beyond just honeycombs. Look at the cracks in dried mud, or even the way basalt columns form. Those hexagonal patterns emerge as forces distribute evenly across a surface, creating this network of interconnected shapes that's incredibly strong and stable.
It makes a lot of sense. But what about snowflakes? They're so delicate and intricate, and yet they also have that six-sided symmetry. How does that work?
That's where the molecular structure of ice comes in. When water molecules freeze, they naturally arrange themselves into this hexagonal lattice. It's the most stable and energy-efficient way for them to bond, each molecule forming bonds at very specific angles.
So the beautiful symmetry we see in a snowflake, it's a direct reflection of what's happening at the microscopic level. It's like a hidden code being revealed through shape.
Precisely.
Mhm.
And think about this. The fact that water molecules always bond this way, creating these hexagonal structures, means that every single snowflake is unique. It's a beautiful example of how order and randomness can coexist, creating these endless variations within a specific set of rules.
It's mind-boggling to think that something as small as a water molecule can dictate the shape of something that we can see with our naked eye. But then there are the ocean waves. I noticed those hexagonal ripple patterns, and that one really threw me for a loop.
Yeah, it is surprising when you first see it. But there's a fascinating explanation, and it all ties back to physics. It's all about wave interference. So imagine waves traveling across the ocean surface, and when they collide, they can either amplify each other, which is called constructive interference, or they can cancel each other out, which is destructive interference.
Okay, I vaguely remembered this from physics class, but I'm a little rusty on the details.
Well, imagine two waves, each one like a little hill of water meeting head on. If their peaks align, they sort of add up, creating a bigger wave. That's constructive interference. But if a peak meets a trough, they cancel each other out, creating a flat spot. And that's destructive interference.
So how does that create hexagons?
Under specific conditions, like when waves are coming from multiple directions and they're interacting in these complex ways, this interplay of constructive and destructive interference can create these repeating patterns on the water's surface. And sometimes those patterns take the shape of hexagons.
So it's like the ocean is a giant canvas, and the waves are painting these intricate geometric designs through their interactions. That's pretty incredible.
It is, and it highlights a key point, that even in seemingly chaotic systems like ocean waves, there are these underlying laws of physics at play, shaping those mesmerizing patterns that we see.
Now, you also mentioned diamonds in your notes, and I'm curious to explore that connection.
Yes, I know they're not hexagonal, but I kept coming back to this idea of diamonds as symbols of strength and resilience. And I was noticing these diamond-like patterns in tree bark riverbeds, even valleys. That's a really insightful observation. Diamonds are the hardest naturally occurring substance we know of, so the association with strength is spot on. And it's fascinating that you're seeing these diamond-like patterns out in nature. It suggests that there's a deeper connection between shape and the qualities it represents.
I was thinking about how diamonds are used to symbolize resilience across many different cultures. It just feels like those sharp angles and hard edges represent an ability to withstand pressure.
Exactly. It speaks to the idea of geometry as a universal language. Even though diamonds aren't literally hexagonal, they still fit into this broader theme of patterns reflecting deeper truths about the world, about the qualities they embody.
So it's not just about the shapes themselves, but also about what those shapes represent, their inherent qualities and the associations that we make with them.
Precisely. Now, you also had some very intriguing thoughts about circles, and I think this leads us perfectly into the next part of our exploration.
Yes. It just struck me that a circle, in a way, is defined by what's not there. The boundary is essential, of course, but it's the empty space inside that gives it meaning. It's like a container for potential.
That's a brilliant way to put it. It connects to so many fascinating ideas. Negative space in art, the efficiency of circles in engineering, even the concept of emptiness in Eastern philosophy. It seems like you're onto something really profound here. And speaking of potential, this idea of circles defining space through emptiness. It actually leads us perfectly to another fascinating topic you brought up, that metallic universe idea.
Yeah, that one might seem like a bit of a jump.
I know.
But I'm thinking about how metals, even though we tend to associate them with being cold and hard, they're actually essential for life itself. And then there's magnetism, this invisible force that seems to connect everything.
I see where you're going with this. We often think of metals just in terms of, their practical uses, technology, construction, things like that. But they play a vital role in biological processes, too. Think about iron in our blood. It's responsible for carrying oxygen throughout our bodies. And then you've got all those amazing alloys, those mixtures of metals that create materials with specific properties, stronger, more flexible, more or resistant to heat or corrosion.
It's like nature's a master metallurgist, combining those elements in just the right way to create the perfect material for the job.
Exactly. And then when you bring in magnetism and electricity, it adds a whole other layer of complexity to this metallic universe concept. These forces, which are actually two sides of the same coin, they shape the universe at every scale.
I remember learning about electromagnetism in school, but it always seems so abstract. Like, how can something invisible have so much power?
It's true, it can be hard to grasp. But let's try to break it down. At the heart of it all are electrons, those tiny particles that are part of every atom. And electricity is simply the flow of electrons. And whenever electrons flow, they create magnetic fields.
So those power lines humming overhead, those are essentially manifestations of this invisible force.
Precisely. And it's not just about the power grid either. Think about the Earth's magnetic field, which protects us from harmful solar radiation, or the incredible magnetic fields generated by stars, which influence the structure of entire galaxies.
Well, that's putting things into perspective.
Yeah.
It's like this invisible web of electromagnetism is woven throughout the entire universe, connecting everything from the smallest atoms to the largest celestial bodies.
And it all ties back to those metallic elements. Metals are excellent conductors of electricity, which means they play a key role in facilitating this flow of electrons and creating those powerful magnetic fields.
It's mind-blowing to think that something as seemingly simple as a metal can be so fundamental to the workings of the universe.
It really is, and it speaks to the interconnectedness of everything. We tend to think of the universe as compartmentalized, but in reality, it's this complex tapestry of forces and elements constantly interacting and shaping one another.
Okay, so we've gone from honeycombs to snowflakes, ocean waves, diamonds, and now this metallic universe woven together by electromagnetism. Feel like my brain is doing some serious stretching today.
And we're not done yet. Remember that note you made about Stephen Hawking and breath? I think it's time we explore that connection. And it might actually tie together some of the threads we've been weaving so far.
Yes. That one might seem a bit out there, but I was thinking about Hawking's fascination with the nature of time, beginnings and endings. And I started wondering, where does the inhale end and the exhale begin? Is there even a definitive point?
That's a brilliant analogy, and it resonates deeply with Hawking's work. He proposed something called the no-boundary proposal, which challenged our traditional understanding of the universe's beginning. He suggested that time, rather than having this sharp starting point like the Big Bang, might be continuous and boundless, much like a breath that flows seamlessly from inhalation to exhalation.
So no definitive Big Bang, no single moment of creation.
Not necessarily. It's more like the universe is in this state of constant becoming, an endless cycle of expansion and contraction, creation and destruction. Even if the Big Bang did occur, it might have been more of a transition than an absolute beginning.
That's a lot to wrap my head around, but it's also strangely comforting. It's like the universe is constantly breathing, always in motion, always evolving. And that sense of continuous flow, It reminds me of something you mentioned earlier, the Tao.
You're right, there's a beautiful connection there. The Tao Te Ching speaks of the Tao as the underlying principle of the universe, this force that's constantly flowing, ever-changing, yet always in balance.
So we've gone from the efficiency of hexagons to the molecular dance of snowflakes, the waves patterns of the ocean, the strength of diamonds, a metallic universe governed by electromagnetism, and now this concept of a universe that breathes like the Tao. My mind is officially blown.
It truly is remarkable how these seemingly disparate ideas are all connected in ways we might not have imagined at first. And there's one more piece of the puzzle I think we need to explore. That intriguing phrase you mentioned, the rigid disciple of death.
Okay, that one's a bit ominous, I'll admit. I don't fully remember what I was getting at there.
Well, let's see if we can unravel that mystery together, if we connect it to the bigger picture. I think you were drawing a contrast between the fluidity and adaptability of nature and the rigidity of many human-made structures.
Now that you mention it, I do remember noticing that everything in nature seems to favor curves, spirals,
Hmm.
those efficient hexagons. It's like nature's all about going with the flow?
Exactly. And you had this idea that anything with a 90-degree angle, anything too square or boxy, it's somehow fighting against that natural order.
Hence the rigid disciple of death.
Right. It sounds a bit dramatic, but I think what you were getting at is that too much rigidity can be unsustainable. It's like trying to force a square peg into a round hole. Eventually, something has to give.
Exactly.
In Taoist philosophy, there's this concept called wu wei, which is often translated as non-action or effortless action. It's about aligning yourself with the natural flow of the Tao, that underlying principle of the universe.
So building a skyscraper with all of its sharp angles and straight lines, that's kind of the opposite of wu-wei.
You could interpret it that way. It's not that human creations are inherently bad or anything, but when we try to impose too much rigidity, too much control over our environment, it can create imbalance. Think about how water flows around a rock in a stream. It doesn't try to force its way through. It adapts. It finds a path of least resistance.
But humans, we love our straight lines and right angles.
Yeah.
We want to control and order our world.
That's part of our nature, too. But the wisdom of Wu Wei suggests that there's a balance to be struck. When we become too rigid, too attached to our own plans and structures, we risk becoming brittle, unable to adapt to change.
So the rigid disciple of death, is that a metaphor for what happens when we lose that flexibility, that ability to flow with the natural order of things?
I think that's a very astute interpretation. Think about ancient ruins, empires that have fallen. Their demise often wasn't solely due to external forces, but also to this internal rigidity, an inability to adapt to changing circumstances.
Wow, it's amazing how this conversation has taken us from the humble hexagon to the rise and fall of civilizations. It really does feel like everything is connected.
And that's the beauty of these deep dives, isn't it? We start with a simple observation, a question, and it leads us down these incredible paths of knowledge, revealing these unexpected connections between seemingly unrelated things.
So what's the takeaway from all this? What have we learned from our journey through hexagons, diamonds, and the fabric of reality?
I think the most important lesson is that the universe speaks to us in patterns. Whether it's the efficient packing of hexagons in a honeycomb, the enduring strength symbolized by a diamond, or the continuous flow of a breath, there's a deeper order, a hidden language that's constantly unfolding all around us.
And it's up to us to pay attention, to keep asking questions, and to look for those unexpected connections, right?
Absolutely. If the universe is this incredible dance of energy and matter, constantly in flux and evolving, who knows what other shapes and patterns are waiting to be discovered? What other mysteries are out there waiting to be unraveled?
Well, I know one thing for sure after this deep dive. I'll never look at a hexagon, a snowflake, or even a simple circle the same way again. Thanks for being such a fantastic guide on this incredible journey.
The pleasure was all mine. Until our next deep dive, keep observing, keep questioning, and keep exploring those fascinating patterns that connect us all.